Hello everyone, welcome back. So in this video we are going to understand the LeetCode problem number 2977. It's a minimum cost to convert string 2. So string 1 we have already, this problem part 1, string 2 we have already uploaded the video in study contest on the daily series. Please go and watch and then come to here to understand this question of part 2. Okay, the very first, this problem looks like a string problem as we have told you yesterday. So but it's actually a graph problem plus a dynamic programming. So previous one is not a dynamic programming, but this one is a dynamic programming, right? And if you miss that, you are guaranteed to get stuck here. So I'll suggest please go and watch string 1. Okay, now the problem we have given is, we have given two string. We know that the source we have given and we have given target we have given, right? So two string we have given, source and target. We are also given a list of substring conversion and each having the cost. So we'll say original we have given these characters has been got changed like this, and to change each string we have given the the cost, right, with a cost. So our goal is very simple to say but hard to do. Okay, this is very simple to say but it's very hard. So to convert the source string into this target, we have some minimum cost we have to find out. So we have to convert the source, this source, into this target, right, with minimum cost, and that minimum cost we have to return, right, using any number of operations. If not able to convert it, return -1 as a answer. So this is what we have understand today. But the problem is that this problem is actually based on graph plus dynamic programming. So keep watching and try to understand. So to understand this type of problem, very first we should understand why the naive approach will fail. Because if you try character by character replacement, right, each character are there, right? So if each character if you want to replace it, right, so this is called a greedy conversion, right, or brute force recursion way we can do that, right? So any of this approach, either you're doing character by character, greedy conversion, or brute force recursion, you will get a wrong answer or TLE. Okay, time limit exceeded we will get. Okay, so the reason is subtle. A conversion can be changed, right, in the chain, and string matters, right? If you'll go in the chain way, right, so definitely the conversion will be in the chain, it will keep going inside, and the substring will matter for each cases, right? So this is what we have to do. Okay, so some operations we have to do. So how this operation will work, so we'll understand from here, right? The very first thing is, each conversion rule is, we have the origin, right? So the original will be changed with the cost. So there will be some cost will be there, is actually directed is in a graph that we have understand started. Because we chain conversion is there, right, as I told you, chain conversion. Let's understand. Let me remove from here. Okay, the very first is this is a graph problem, right? Because each conversion rule is, I said, is there is a original, and to convert this original we have changed with cost, right? So each conversion rule says from the original to the changed we have some cost, and it is actually a directed is in a graph, right? You know the directed is in the graph, right? Because we can change conversion, let's call it from A to B, B to C, C to D, like that, right? So we must compute the minimum cost between every pair of the substring. Okay, so you understand the minimum cost we have to find with every pair of the cost, right? So I'll suggest please go through this statement so you will understand basically. Okay, so we want to compute the minimum cost between every pair of the substring, and then this screams like a Floyd Warshall, right? If you remember in study videos, right? So this is what the concept behind, because this is a graph problem, and graph problem will be solved usually the Floyd Warshall in this type of problem, right? So very first that we know that we have to do the some conversion, right? Means we should do as per the standard of the Floyd Warshall, right? What we need to do, we will pre-compute all conversion cost. If you remember, we have done in study video also, right? Very first we will compute the pre-compute all conversion cost. So before touching the string itself, right, we will build a graph of all the string and will run the Floyd Warshall algorithm, right? Okay, so the cheapest cost to convert any substring into other substring we can have already using the pre-compute thing, right? So this pre-processing is a backbone of the solution, or you can say for this algorithm, right? Now there is a concept. If you have gone through my channel, you have seen that I have created a playlist on DP on the string. Okay, so DP on the string is a concept where we can work on this type, because now it comes the dynamic programming, and dynamic programming will define DP at I, we can say that, right? DP at I. So when DP at I, it means the minimum cost to convert, let's call any source, right? Source will start from I to will go to the end, right? And this should be converted into the target from I to the end. Can we say that? So we have to define the DP on the string like this, right? So each DP at I, we have to say is nothing but the minimum cost to convert from source I to end, and to it will go to the target to the end. So if you'll talk about the base case, right? So in the DP, it is very important to understand the base case. So if we have processed the whole string, right? Let's suppose the complete source is getting interchanged into the target without without the cost, right? Or you can say the cost for if you're changing whole string as a substring. Whole string is also a string, right? Let's suppose A, B, C, D is also a substring. So if you're converting the complete source into the target, cost will be 0. So this will be our base condition. It means DP at N is nothing but 0. Understand? So DP transition is very important to understand. Let's try to understand here. Okay, so what I'm saying that let's understand DP transition, right? What is DP transition? So at every index I, we have two choices, right? The choices, one is, we can say characters match, right? If the character is matching, either all the characters will match, right? It means we'll say if source at I is equal to the target at I. So it means both is matching. So we will skip it. What we will do? Skip both. Will not do anything. It means we'll say DP at I is nothing but DP at I plus 1. Because character is matched. In other case, when character is matched, then this case will work. Means all the characters is matching, right? Now option 2 is we will replace a substring. Remember? So when the character is not matching, means we will replace it. It means we will try every substring from our conversion rule, right? What are the conversion rule is there? Very first conversion rule is that if the source substring matches. There is substring, right, and the source substring is matching. Yeah, they are matches. Another, the target substring exists, correct? And the third is the conversion cost is finite, not infinite. It should be finite. Then if any of this is there, means we have to replace a substring only if the source substring matches, target substring exists, and we have to the conversion cost is finite, not infinite. If the conversion cost is finite, then only we will then update DP, right? How the DP conversion happen? If the character matches, only if the source is equal to the target, we will skip both. DP at I equal to DP at I plus 1 we will do. In case other case is the characters is not matching, means we have to replace a substring. It means what are the things only if we will do if the substring source matches, if the substring from the target is existing, and conversion cost is finite, it's not infinite, then we'll update our DP, right? So let's understand how DP conversion will happen. Okay, so very first I'll write here. Okay, so I'll say DP at I is nothing but, we'll say, mean between A and B. So A is nothing but DP at I, and we'll say we will take the conversion cost, we can say conversion cost. This is a function type, we'll say, or value we'll say, or we'll say DP at I plus length. Okay, so DP at I is nothing but the mean of DP at I and conversion plus DP at I plus 1. You can take this screenshot when you do the coding, it will help you. Okay, what I'm saying that very first we'll do the DP transition, right? In the DP transition, if the character is matching, right, only if the source is equal to the target, then we will skip both and we'll update our DP at I is equal to DP I plus 1. Then other case will be that we will replace the substring in case if the characters are not matching. There will be only three conditions is there: if the source substring is matching, if target substring existing, and conversion cost is finite, right? Then only we will update the DP. How will update the DP? DP at I is equal to minimum between DP at I and the conversion cost plus DP at I plus length. So this is what we have to find, guys, and we will say okay that we will update like this. Okay, so very first, why this will work, right? We never recompute the conversion path, we never go with the brute force on all substring, we always build from the end of the substring forward, right? And why this will work, you know now, right? That's why this is this will pass and it will work. Okay, so if we'll talk about the conversion cost, right, let me tell you how we'll do the conversion and how will you define the conversion cost. Okay, so very first we have given these things, right? We define the infinity, right? Then we know that this is our source, and if the target is not matching, length is not matching, both lengths should be equal, otherwise return -1. Very first rule is that we have to collect all substring which is appearing in the rules, right? So we'll take a map, let's call ID, and this is nothing but the index. So we'll say okay, from the original we'll get the string, right? And we'll check if it contains the string, we'll keep adding the id dot put, and we'll say all the indexes we are getting to put here, right? The substring what is changed, that will keep also adding here. Like that we'll add onto the string, there will be a string and there will be integer like this, right? So we are collecting all the substring. Okay, so this is what we have. Now when we come to the building the what do you call the matrix, right? So you know how to do that. Very first we need a matrix, then we'll make a loop and we'll fill with the infinity value, and initially the value will be 0, right, the very first one. And then we'll check the direct edges, like a direct conversion we have done yesterday. So we'll define the minimum value, we'll keep adding over the this matrix, and then we'll apply we will find the minimum one. To find the minimum one for all the k, we'll go for all the I, all the j will go, right? And if it is infinite, we'll continue, otherwise we'll find the same thing, the minimum, and we'll keep this thing ij, ik plus kj. Okay, we'll update our minimum here. Now coming to the dp on string on position, very first we'll define the dp, we'll fill it with the dp, and dp at n will be initially 0, and all these three conditions will be there as we have discussed. If all the character is matching, right? So we will start from the last character to the first character, will keep going. So we'll check if the substring all the characters is matching. You just need to skip it. So dp at I is nothing but dp at I plus 1 will do, and we'll try all the substring replacement. How? You will keep going over the key set, right, and you will check the length. If the length is greater than this, you will continue. Similarly, if source start with from and I, will continue, and same will do with the 2. So we'll keep checking these two values. Okay, now you have u and v, the from and to. If both is at this value is infinity, continue, otherwise find the minimum value between deep, means when the character is not matching, right? It means all these cases you have checked already. Now you define the mean. So dp at I, as I told you, you will have some value will be there, and dp at I plus length we will do, and you will find the dp. Okay, so all those cases that we have talked about, right? So if the source substring not matches, target is existing, and conversion cost is there, is finite, right? Then we'll update the dp. So we'll use dp at I, conversion cost will be there, plus dp at I plus length. This is what we have done here. Okay, so this case will work like this, right? And you will update our dp. Now your dp is fulfilled, right? And then you will check if it is infinity, return -1, otherwise there will be some value will be at dp at 0, return that value. Okay, this is what we have, guys. I will put this code into the comment box, you can get from there.